Hello guys, this is my first video and in this video we are going to learn binary search. So let's start. First of all, we need to know what is linear searching. So let's say we are given an array 1, 2, 5, 4, 3, 2, 6 and we are asked to find whether 6 is present or not. So in linear search what we can do is this. First we go to index 1 and see if it is equal to the element we are searching for or not. If it is equal, we return true, and if it is not, we proceed to the next element. We go to the next element. 2 is not equal to 6. We have to find 6. We go to the next element. 5 is not equal to 6 and so on. We go to the last element and this is equal to 6. So we have found our element. So we can return true. We can return true. But what is the time complexity of linear searching? The time complexity would be big O of n, which is very slow for this small task. So what can we do? We can apply binary search because binary search time complexity is O of log n. It is very much better than O of n. So when can we apply binary search? First of all, the array should be sorted. Let me just erase this array and increase size of my array. Yes, this is good. So let's say we have a sorted array 1, 2, 3, 3, 4, 5, 6. So how can we, and now we need to again search for 6. So what can we do in binary search is we can always look for the middle element and reduce our array size to half of the current size in each operation. So let me just illustrate this to you. First we go to the middle element. So this middle element is smaller than the element we are looking for. So tell me, should we need to search 6 in this array or not? We do not need to search 6 in this array since 3 is already less than 6. We know that the array is sorted, so this would just be extra operations. So we do not need to search 6 in this array. We can search in the right half of the array, that is this array. So what we can do? We can again look for the middle element of this new array. So the middle element is 5, which is again smaller than the element we are looking for. So we can now again go to the right half of this array. So this is the remaining array. We can check the middle element of this array, which is 6, and we can return true since we found our element. So what is the time complexity of this method? I have already told you that it is log n. So let's prove that the time complexity of this method is log n. So how can we prove that the time complexity of this method is log n? So let's see how many operations we have to do to find our answer. First of all, we we reduce our array size to n by 2, and we again reduce this size to its half, which is n by 4, and we proceed until we get our elements. Let's say we reach to n by 2k. Now this many operation we have to do, number of operations. The number of operations is k, because this many times we reduced our array size. So the our time complexity is n by, no, this is no time complexity, this is the final array size that we have reached, and uh, the number of operations is k. So let's say this is what, let's say this is c. So we can say n equals to c into 2k. So we can take log here and we'll get k equals to log of n. So we had to do this many operation. So our time complexity is of log n. Now, what can be the applications of binary search? First of all, binary search is not only applied to search an element, it can also be applied in many things. Let me give you an example. Okay, our board is nearly raised. Okay, now let me give you an example. Let's say I have a linear function. Linear function means not linear increasing or decreasing function. Our function can be like this or like this. If the function is increasing or decreasing, we can always apply binary search. So let's say the middle value is this. If it doesn't satisfy some conditions, we can always go to the upper half or the lower half. So we can see that binary search can be applied in many ways, and one of those applications is finding of an answer. Okay, finding answer. Let's say we have a question in which we have to find the answer based on some conditions. So we can see that, let's say we have to find an answer. There is a function can. There is a function can in which if we pass the value, it will give me true or false. It can give me true or false. And based on those values, I can proceed forward. Let's say there are some possible values to our answer, and we are searching the smallest value is this and largest value is this. and we look for the small element middle element, sorry, and if it returns true, let's say this condition is true, that if this is true, then this is true for all these values, and we have to find the maximum value which is possible. Let's say if this is true, then this is possible for all these values. Then we need to search only this portion of the answer. So we will again look for this middle element. If this is false, let's say. So we know that our answer is greater than this element but should be smaller than this element, because we know that if this is false for this, then the condition is false for all these elements. So our answer lies between this. So we can search for the middle element again. If it is true, then we know that the answer will exist for all these values. So we need to search only for this portion. And in this way we can apply binary search to solve many kinds of problems. We can make a function can which will search for the condition if this value satisfy or not, and we can proceed further. So that's it for this video, guys, and I will solve a question on binary search in the next video. Thank you for watching this video, and please subscribe to my channel.